Bismillahirrahmanirrahim. Assalamualaikum and hi everyone. Welcome to my YouTube channel. Have you subscribed my YouTube channel? Okay, if not yet, please subscribe my YouTube channel now and don't forget to press the bell icon and you will never miss any update. Right, for today's topic is about 5.2 alkene. Right, so in our daily life, okay, you can see a bunch of banana. It does not ripen together. Okay, why? So this is the reason. Okay, actually, for the ripened bananas, it will emitted a gas that is called ethene. Okay, ethene gas react as a chemical messenger, so it will induce bananas in a bunch to ripen together. Okay, that's why kalau kita tengok satu tanam pisang dia tak masak serentak. Ni masak satu-satu. Pisang yang masak tu dia akan mengeluarkan gas ethene. That's why lama kelamaan satu tandan dia akan bertukar warna menjadi warna kuning. Okay. Alright, so these are the things that you are going to learn. So a lot of things under 5.2. Okay, however, I already divided into 4 parts. The first part is about nomenclature. Second part, preparation of alkene. So there are two reactions involved. That is dehydration of alcohol and dehydrohalogenation of alkene. Alright, next is about chemical properties. It's a lot of chemical properties here. And the last part is about reaction mechanism. So they altogether they are 4 parts, okay, for this topic. Alright, so the first part is about nomenclature of alkene, right? So alkene, it has general formula CnH2n, where N should be equals to 2, equals to 2 or greater than 2, and it has functional group carbon-carbon double bond. It is saturated hydrocarbon since it has a carbon-carbon double bond, and other atoms or group, other atom can be added, okay, to the carbon-carbon double bond in via simple addition reaction. So this is carbon-carbon double bond. Alright, okay, next, at the restricted rotation about C double bond C, alright. Okay, so it can exist as cis-trans isomerism. Okay, however, it has a requirement at the restricted rotation. It must have two different groups attached to it in order to exist as cis-trans isomerism. Alright, so for cycloalkenes, the general formula is CnH2n minus 2. So as we already know, when the compound becomes cyclic, so it will short 2 hydrogen. Dia akan kurang 2 hydrogen in order to form cyclic. So as you can see, general formula for alkene for open structure CnH2n, whereas for the cycloalkene it lost 2 hydrogen, CnH2n minus 2. Okay, alright, and then cycloalkene also can show isomeric to alkyne, okay, because it has the same general formula. Okay, for example, this is cyclobutane, alright, cyclobutane. It can show functional group isomerism, okay, since it has the same molecular formula C4H6. Okay, this is cyclobutane and this is butane, okay. Right. Okay, next we take a look at how that you can name for the switch or unbranched alkene. Alright, so we start with 2 carbon. So 2 carbon, alright, so the name is ethene. Okay, from the previous lesson, topic alkene, the suffix is A and E, alright. So that's why for the alkene name, replace A and E with E and E. Okay, to show the name of the alkene, alright? Okay, and then 3 carbon is what we call propene, propene is 3 carbon. Alright, next, butene. Butene, we have 2 possible structure, 1 butene or 2 butene. So 1 butene because, the first carbon has the carbon-carbon double bond. Okay, so for example, like this. So this is carbon 1. carbon 2, carbon 3, carbon 4. So because the position of the double bond is located at carbon number 1, whereas for butane, position of the double bond is at carbon number 2. You see this, the name pentene, so you have to understood that the position of the carbon-carbon double bond is located at the first carbon. So this is the first carbon. Okay, right. Okay, and then this is CH2 bracket 2, which means CH2 repeated 2 times. So carbon 3, carbon 4, carbon 5. Okay. Okay, 6 carbon is what we call hexene. From previous lesson, number the carbon chain with the nearest to the functional group. Okay, 1, 2, and then this is meaning that it's repeated 3 times. 3, 4, 5, 6. Alright. So for the 7 carbon is heptene, 8 carbon is octene, 9 carbon is nonene, and 10 carbon is what we call kene. Alright. Okay. Right, so this one, as usual, you have to remember all of this. Alright, so we take a look how that we can name for branch alkane. So meaning that it has a subsequent. Alright, so the first part, okay, the first step, what should you do? So you have to determine the parent name by selecting the longest chain. Okay, that contain double bond. Okay, maksudnya kena cari paling panjang dan mesti lalu dekat carbon-carbon double bond. Okay, and then kita drop A and E. Okay, and then chain it into E and E. Alright, so for example like this, the longest carbon chain is 4. 1, 2, 3, 4. Okay, and then when the chain contain more than 3 carbon, so for example like the example 1, 2, 3, 4. For carbon, a number is needed to indicate the location of the double bond. So meaning that starting from carbon 4 and onwards, so the position of the double bond, you have to write. You have to indicate the location. You have to write the location, what number. The chain is numbered starting from the end closest to the double bond. For example, like this example. Okay, kalau tengok sini, the nearest is from the left side. So that's why this is the first carbon, second, third, and fourth. And this one become the substituent. Okay, next indicate the position of the substituent by number of the carbon atom to which they are attached. Yeah. Right, so the name for this alkene is 2-methyl. Okay, 2-methyl is position of the methyl. Okay, 2 here is referring to the position of the double bond. Okay, butane. Okay, not 3-methyl. So 3-methyl means that the substituent get larger number 3. This is wrong. So the correct answer is 2-methyl 2-butene. Alright, so we try again for this structure. First, we have to find out the longest carbon chain. Alright, and must contain double bond. Yang paling penting mesti ada double bond. Alright, so for this structure, we have 6 carbon. Longest carbon chain is 6 carbon. Okay, next, how to number? So must be numbered closest to the double bond. So for this structure, from left to right, untuk structure ni, and there are 2 methyl group here. Okay, so what is the name for this structure? Okay, the name here is 2,5-di. Di because we have 2 methyl. 2 hexene, 2 here because the position of the double bond is located at carbon number 2 hexene, not 2,5-dimethyl 4 hexene. So meaning the position of double bond is larger number. Okay, so kita kena utamakan double bond dan juga substituent. Dia tak boleh pula kita utamakan substituent. Dua-dua lah sama penting. Okay, so now we take a look how to name for cycloalkene. So number the carbon atom with a double bond as 1 and 2. So maksudnya kalau yang ada double bond tu mesti 1 and 2, carbon 1, carbon 2. Okay, which give the substituent encountered first with a smaller number. Maksudnya mesti start at carbon double bond, carbon 1, carbon 2, pada carbon double bond tu, and then substituent mesti dapat lowest number. Tu syarat dia lah, simple je. Okay, so dia boleh jadi clockwise ataupun anti-clockwise. Macam contoh sini memang dia clockwise lah. Okay, and then kita buat anti-clockwise. Kalau this carbon 1, this carbon 2, substituent dia akan dapat nombor 2 kan, besar. And that's why kita start sini, clockwise. So nama dia akan jadi 1 methyl cyclopentene, bukan 2 methyl. 2 methyl masuk substituent tu dia akan dapat nombor yang lebih besar, salah So dua-dua sama penting. Dua-dua sama penting. Okay. Alright. So kalau for this example, okay. So dia ada two different substituents. So we have methyl and ethyl. So you have to arrange according to alphabetical order. E dulu, lepas tu baru M kan. Okay. And then kalau kita buat okay, let's say kita buat anti-clockwise. Carbon 1, carbon 2, carbon 3, carbon 4. 5, 6. So 4 and 6 is the position of the substituent. However, if you number for clockwise rotation, 1, 2, 3, 3 and 5, smaller number of substituent. So for this structure, so kita akan pilih clockwise rotation. 5 ethyl, 3 methylcyclohexene. Okay, next. Okay, so how to name a stereoisomeric alkene? Okay, so just add prefix. Nama depan dia cis. Okay, italic. Trans also italic. Okay, and then how that we can know cis-trans isomer? So very simple. So you have to focus on two identical group. So if two identical group attached on the same side of carbon-carbon double bond, so the compound is known cis isomer. If two identical group or atom is opposite side, so that is trans isomer. So we take a look at this both structure here. So we focus on hydrogens. For the first structure, both hydrogen attached at the same side of carbon-carbon double bond. So this is cis isomer. Second structure, hydrogen is attached at opposite side. So therefore this is trans isomer. Okay, where should we start numbering? Okay, of course, closest to the double bond. Okay, 1, this is carbon 1, carbon 2, 3, carbon 4, carbon 5. Okay, alright. Okay, so what is the name for this stereoisomeric alkenes? Okay, alright. So for this one, you have to add cis hyphen 2-pentene. 2 here is the position of double bond. Okay, why hyphen here? Because huruf. Okay, alphabet and also 2. Huruf dengan nombor hyphen. Okay, nombor dengan huruf hyphen juga. So the other one should be trans 2-pentene. So this is a comparison for the boiling point. Cis isomer have higher boiling point compared to trans. Why? Because cis isomer has net dipole moment. So meaning that the bond dipole cannot be cancelled out. So kalau kita lukis, so dia akan point ke arah carbon lah. Carbon ni kan more electronegative. Bond dekat sini dia non-polar sebab carbon-carbon same electronegativity. So tak boleh nak cancel. Okay, so dia ada net dipole moment. So dia polar. So dia have stronger van der Waals forces. Okay, this one is referring to the dipole forces. Okay, alright. So for the trans isomer, so okay, the bond, the net dipole moment is equal to 0. Okay, since both dipole moment is opposite side, okay, and be cancelled out. Alright. So that's why trans isomer is a non-polar molecule and it has weaker van der Waals forces that is referred to the London dispersion forces. Okay. Alright, next. Okay, move to the next slide. Alright, so this is tutorial question number 1. So we try to name, okay, the selected is 1B. Okay. So kalau soalan bagi macam ni, dia dalam bentuk cis-trans isomer, jadi kena letak nama depan cis ataupun trans. Kalau kita fokus pada H, H ni nampaknya dia opposite side, so dia trans. Okay, and then macam mana nak nomborkan dia? Okay, Right, so kalau nak nomborkan dia, cuba tengok mana yang dekat dengan carbon double bond. Kalau kita start triangle, 1, 2, 3 dah jumpa carbon double bond. Kalau start daripada bawah ni, 1, 2, 3, 4. Jauh dah kan? So, start di sini. 1, 2, 3, 4, 5, 6, 7. Alright, so apa nama dia? Trans. Kena italickan, sengitkan sikit tulisan. Okay, dash. Okay, position of the double bond 3. Okay, 7 carbon is what we call heptene. So simple Okay, kalau dia tak bagi, dia buat bentuk biasa je. Tak adalah nama trans ni. Kita bagi nama dia 3 heptene sahaja. Okay. Alright, so kalau bagi macam ni ada 2 double bond. Dengan syarat, first kita akan cari longest carbon chain dan mesti lalu dekat carbon-carbon double bond. Dia tak boleh double bond tu satu jadi parent, satu jadi saksi tu tak boleh. Okay, dalam kes ni nampaknya saya bulatkan yang ni lah dia punya parent dia dia bersambungan dan paling panjang. Okay, alright, ini akan jadi dia punya substituent. Nampak macam bentuk Y, ada cabang 2, 3 carbon, this is isopropyl. Okay, isopropyl. Jadi kat mana nak start? Mesti dekat dengan carbon double bond. Mesti dekat sini lah. Ni carbon 1 ni lah. 1, 2, 3, 4, 5, 6, 7, 8. Untuk structure ni ada 2 pula double bond. Macam mana kita nak bagi nama dia kan? So first kena letak dulu substituent ni. Letak nama substituent dekat depan. 3 isopropyl. Okay. Next, kita letak position of both double bond. So, kita jumpa carbon 1, 6. Kan, carbon 1 and carbon 6 dah ada double bond. Okay, and then kena letak, kalau ikutkan kalau satu double bond, 8 carbon octene. Ni akan jadi octadiene. Okay. Octa. Lepas tu kena tambah di ni maksudnya ada 2 double bond. Diene. Kalau tak octene kan. Octene. Ni kan jadi octadiene. Okay, next. Tutorial question number 2. Macam mana cara nak lukis. Okay, so kalau tak tahu nak lukis cis-trans, kita lukis nama belakang dulu. So kita lukis belakang dulu ya. Belakang dulu start dengan apa? Belakang tu apa? Maksudnya start dengan dia punya ni. This one parent, octene. Octene 8 carbon. 1, 2, 3, 4, 5, 6, 7, 8. So mana nak start double bond? Tak kisahlah kiri kanan. Katakan ni carbon 1, carbon 2, carbon 3 ada double bond. Okay. And then carbon 1 tadi ada chloro Cl. Lepas tu kita lengkapkan yang lain. Yang ini karbon hujung tapi ada satu substituent dia kata CH2. Karbon tengah CH2. Yang ada double bond ni 1, 2, 3. So ada satu H kat sini. 1, 2, 3, satu H. Karbon tengah tak ada substituent CH2. 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 Karbon hujung CH3. Tak ada substituent CH3. Okay. Next, kita fokus pada C double bond C. Carilah okay, yang two different group attached pada carbon-carbon double bond tu. Macam ni. Okay, lepas tu baru kita buat bentuk. Saya panggilkan bentuk tu ke bentuk butterfly. Okay, so bentuk butterfly macam ni. Okay. Kita tengok kita kalau yang samanya adalah H Kalau C same side. Jadi kita H kat sini same side. Atas atau bawah tak kisah. H dah kita lukis. So, carbon mesti bonded dengan carbon Bukan carbon bonded tu H. Terbalik kan. Okay, lepas tu C H2. Sini nak letak Cl di belakang ni pun boleh buat bracket lah macam ni. Okay, next yang ini seterusnya carbon mesti bonded tu carbon. Sambung je ada 1, 2, 3, 4 Okay, so kira balik betul ke 8 ni? 1, 2, 3, 4, 5, 6, 7, 8. Betul Right, C pula. C ni, first of all, identify the parent name. So this is cyclobutene. Okay, lukis dulu cyclobutene. So cyclobutene tak boleh kita buat bentuk. Let's say awak buat bentuk macam ni. Macam gini pula. Macam ni salah ya. Nampak tak? Yang ini kan lebih panjang daripada yang ini. Ini kan single bond. Ini pun single bond. Kenapa ni pendek, ni panjang, ni salah. Jadi kena buat betul-betul bentuk square. Mana letak double bond, mana-mana pun tak kisah. Let's say saya letak di sini. Ni carbon 1, ni carbon 2. Jadi carbon 1, sini tengok. Ada dichloro Cl. Sini ada Cl. Ni carbon 1, carbon 2 ada methyl kan. CH3. Okay, carbon 3. 1, 2, 3. Sini ada Cl. Senang je kan? Dah selesai. Okay, so I think that is end of part 1. Alright, so we continue. And for the second part is about preparation of alkene. That's all. Thank you.